Hello, scholars. It's Mrs. Gregerson. I have the pleasure of reviewing with you radicals once again. We're going to take a step further and work on a couple other skills, but let's first review what we learned about simplifying radicals last week. So first of all, remember that we always have to have simplify by taking out the perfect square numbers, so there's nothing else left underneath the radical. We always have to leave it in simplest radical form. So we're getting ourselves so we're not dependent on the calculator anymore. I'm still fighting this cold, so please forgive me. So what do we do first? Well, first we have to look and see if the number underneath the radical is a perfect square number first. And we know 80 is not a perfect square number. So remember, we're going to look for a perfect square number that I can factor out of 80. And I want to get the largest one possible. Now, a lot of you said, well, I know 4 comes out. Yes, 4 is a perfect square that comes out of 80, but it's not the largest one. The largest one you can have is 16. Because 16 times 5 is 80. Well, what's the square root of 16, my friends? Well, that's 4. So remember, now we go negative 5 times 4, and we get a negative 20 root 5. Now, a lot of you hopefully are getting to the point where some of this you can do in your head and almost go from the problem to almost the answer. But it gets a little bit harder at times. All right, so let's look at the next one. All right, so the next one this time we have actually some variables with it. So we got the square root of 49, x cubed, y to the 8th, z to the 9th. So we're going to sit there and remember we're going to divide it into two radicals. The one on the left is what our perfect square numbers go into, and then the one on the right are the ones that I can't simplify any further, that are not perfect square numbers go. So the first thing is 49 is a perfect square number, so we remember we put it to the left. And then we looked at x cubed, and the largest perfect square number that comes up x cubed is x squared, but then we leave an x underneath the radical on the right, because x squared times x is x cubed. Remember that y to the 8th, that's a perfect square number because it's even. And then we got z to the 9th. Well, an odd number isn't a perfect square number, but z to the 8th is, and so we leave a z. So then we take out our perfect square numbers. So square root of 49 is 7. The square root of x squared is x. The square root of y to the 8th is y to the 4th. Square root of z to the 8th is z to the 4th. And then we have the square root of xz. All right, great. Not too bad, is it? All right, well, now let's keep going. Remember, then we added subtracted radicals. Remember, we can't add and subtract radicals until they're in simplest form and if they have the same number underneath the radical. So on the first one, let's simplify both terms first. So I get 3 times the square root of 48. So I get 3, 48, the perfect square number comes out, that is 16. So we got root 3. Rewrite that a little bit bigger. And then here, I got square root of 27. Well, that's square root of 9 times the square root of 3. Well, the square root of 16 is 4. 4 times 3 is 12. So we got 12 root 3. Square root of 9 is 3. 3 times 4 is 12, and I get 12 root 3. Oh, look! 12 root 3 minus 12 root 3. They're exactly the same radical underneath. And I can just add or subtract my coefficients now. Well, 12 minus 12 is 0. Well, am I going to really write my answer as 0 root 3? Or really, what's 0 times root 3? That's right. The answer is 0. Gotta like it when it's easy like that. Okay, let's look at the next one. I got the square root of 288 plus 3 times the square root of 50. Now, a lot of people are like, oh my goodness, large numbers. Remember, you should have memorized sometime in your high school or middle school career, you have perfect square numbers at least to 20 squared. Well, what's 12 squared? Well, that's 144. Well, guess what's 144 times 2? Square root of 288. So then I look at square root of 150. Well, 150 is not a perfect square number, but I know 25 can come out of it. And then I'm going to be left with 6. So 6 times 25 is 150. So what's the square root of 144? Well, that's 12. So it'd be 12 root 2 plus, well, square root of 25 is 5. 5 times 3 is 15, and that's 15 root 6. So my answer for this one, because I cannot combine these anymore, because root 2 and root 6 are not the same number underneath radical, is 12 root 2 plus 15 root 6. All right, I think I might be coughing a lot in this video, and it makes me kind of sad. All right, guys, so now we're going to just practice multiplying and dividing radicals. Now, here's the thing you need to remember about multiplying radicals first. When you're multiplying radicals, the easiest way of thinking about doing this It's the same idea when you were like multiplying numbers together with variables. How did I multiply 3x times 2y? Well, you multiply 3 and 2 together. So you got 6. And then you can't multiply x and y together, so you'd get xy. Or what if I had something like 6x times 2x? What would you do? Well, first you always multiplied 6 and 2 together to get 12. And then you multiplied your two variables together because they were the same. And then you got x squared. Well, we kind of take the exact same approach when I'm multiplying radicals. You multiply the numbers out front together. So like here we got a -5 times 4. I'm going to write a little bit more than I normally would right here. And then you multiply the numbers, the radicals underneath together. So you get there 8 times 3. Now what does that give us? Well, it's a -20 times the square root of 24. But remember, I can never leave radicals without making sure it's in simplest radical form. Well, I can take a perfect square number out of 24. We know that's going to be 4 times the square root of 6. Well, what's the square root of 4? 2. So that's -40 root 6. So a lot of times people will go from the first part to this step and then they end up at the last step. But it's really not that bad again, but it's really you just got to combine. But you also always have to ask yourself, is this in simplest radical form? Okay, so let's look at our next one here. All right, so I'm going to multiply 36 times 8 together. Now, okay, totally, let me back up for a moment. What's understood to be in front of both of those radicals? I hope you all would say a 1. So I'm really not worried about multiplying 1 times 1, but I do want to combine what's underneath my radicals together. So I'm going to go 36 times 8 first. So we get 36 times 8, which I do believe is 288. And then we're going to multiply your x times your x squared. And so that gives me x cubed. And then I can take the square root, make sure I'm simplifying it out. That's 144 and x squared. What left is 2 and x. And we get, with that, 12x times the square root of 2x. Now, I want you to know there's more than one way you could have done this one. So let me see if I can do it in a different color and show you the same process here. All right, what instead if I simplified my radicals first? So, and I don't always suggest doing this, but sometimes it works really well. So what if I simplified instead, and I didn't change the color I wanted to. Let me go change it here. What if I go ahead and I simplify the square root of 36x? Well, that becomes 6 root x. Well, what is 8 square root of 8x squared? Well, that simplifies down into 2x root 2. Then my question is, can I still multiply these together like the other ones? So remember, this right here, I am literally just redoing this. I'm multiplying the numerators together, so not numerators, oh, I just said that wrong. The numbers out front together. 6 times 2x, well, that's 12x. Then I multiply what's underneath the radicals together, x times 2. So you write that square root of 2x. Did I get the same answer here and here? Yeah, I did. So it's really not that hard to do it either way. Now, I'm erasing this last one. You can rewind it if you want to. I can do that fairly quickly, but a lot of you, I would still suggest is just stick with it, multiply it together, and then simplify. Now, the next one that I have for you is we're actually going to multiply fractions together. Remember, when you're multiplying fractions together, you multiply numerators together and denominators together. The rules don't change, so when we're multiplying it. So I multiply the numerators together. Well, that's really just root 20 times root 3 over root 5 times root 5. Well, multiply them together. So I get the square root of 60 over root 5 times root 5. That's the square root of 25. Now I got to keep simplifying that. Well, the square root of 25 is 5. Well, what about the square root of 60? Well, that simplifies into square root of 4 times the square root of 15. Well, what's the square root of 4? 2. So I get 2 root 15 over 5. So it's 2 root 15 over 5. Now, the key thing is you always have to double check when you're working with fractions is you have to make sure that like any other fraction before, everything's still in simplest form. So since 2 and 5 cannot reduce, we're okay leaving it that way. So I get 2 root 15 all over 5. Now, please excuse me, guys. So sorry. Well, here we got simplifying radicals, fractions here. Now, how do you simplify fractions? Well, the cool thing about fractions is you could literally, you can rewrite it. So instead of having it the square root of 8 over the square root of 9, I can rewrite it like this, the square root of 8 over the square root of 9. And then you can just simplify each one individually. Well, what does the square root of 8 simplify down to? Now, hopefully by now you have this memorized. It's 2 times the square root of 2. What's the square root of 9? 3. So it's just 2 root 2 over 3. Not real bad, was it? Also, we have the next one. We got 2 over the square root of 7, that quantity squared, which really, remember, is just 2 times square root of 7 times 2 over the square root of 7. Or you could write it as 2 squared over root 7 squared. So either way, it's the same scenario. So what's 2 times 2? Well, that's 4. What's the square of 7 times the square of 7? Remember, we multiply them underneath together. That's the square root of 49. And so I end up getting 4 over 7. Now I want to kind of notice something here. Notice I rewrote this like right here. Root 7 squared. What did I get for an answer? 7. So what does the squared and the square root do? Yeah, they simplify each other out. Let me show you that again. What if I had root 3 squared? Well, that's the same thing as going root 3 times root 3, which is the square root of 9, which equals what? 3. Look, squaring a square root, the number comes out. Let me show you something else that I think is really cool. What's the square root of 3 squared? Well, 3 squared is 9, and I get 3. So what does the square root and the squared do again? Yeah, they simplify each other out, so you get the number underneath. Isn't that cool? It's just 3. It's just some shortcuts, hopefully, that you remember from Algebra 1. Now, there is a key with simplifying radicals. First of all, with fractions and radicals, so when I'm dividing, remember a fraction is just a division problem, you can never have a radical in the answer of your denominator. So how in the world can I simplify this? Well, there's a couple different approaches that you could take. So on this very first one, I can use the idea like I did up here on A. Now here we got 8 over 9, and I rewrote it as square root of 8 over square root of 9. Well, here's my question. Can I rewrite this as 3 over the square root of 3 over 27? That's right, because I can now simplify it. What's 3 and 27? Doesn't that reduce down? Yeah, into 1/9. Now I can take the square root of 1/9. You could then rewrite that in your head. And I say do it in your head. I'm writing it down so you know what I'm doing. What's the square root of 1? 1. What's the square root of 9? 3. So that gets us 1/3. No radical in the denominator. We are okay. That's in the simplest form. Now on the next one, a lot of times what I suggest to people, especially if you can see the 2 and the 75, they don't simplify out, so I can't work with my radicals. A lot of times I say go ahead to make it easier on yourself and simplify the radical in the denominator first. So I go like 3 root 2 here, and I say, okay, the square root of 75, what does that really simplify down to? Well, that ends up being 5 root 3. When I look at this, I have a simplified radical in the numerator, one in the denominator, but the problem is I have what's called a radical in the denominator. So we have to use what's called rationalizing the denominator. So to rationalize the denominator, I will multiply both the numerator and the denominator by the same radical. Now, what radical am I going to choose? Well, I'm going to choose the one that's in the denominator, because look what happens. The numerator becomes 3 root 6. The denominator becomes 5 times what's the square root of 3 times the square root of 3. That's the square root of 9. Well, guys, what's the square root of 9? That's right, it's 3. So I get 5 times 3, excuse me, which is 3 root 6 over 15. I no longer have a radical in the denominator, but here's my question. Am I in simplest form? The answer is still no. because I can take a 3 out of the 15. So I have to still remember, I still have to look right here to make sure I can simplify anymore or not. Well, in this case, I can take a 3 out, and that comes root 6 over 5. Isn't that cool? Just be very careful. Always think simplest fraction form, simplest radical form, over and over again. All right, so the next one, don't let it complicate you. Let's just take it as it is. I have two fractions multiplying. Yes, there's radicals and stuff with it, but go across. You get 8 times the square root of 5. Then I get the square root of 6x squared times the square root of 2. So that gives me the square root of 12x squared. Well, now I'm going to simplify my radicals. Well, what can come out of 12x squared? Well, a 4x squared and a 3 is left. So we're going to keep simplifying. So I get 8 root 5 over, what's the square root of 4x squared? 2x root 3. Now, I do not want the radical in the denominator of a fraction. So what do I have to do? Multiply the numerator and denominator. It's the process called rationalizing the denominator. And I use the number, again, remember, what number do you choose? You choose the one that's in the denominator of your fraction. And really, remember, you're multiplying. This whole thing right here is I'm multiplying by a number 1. So I'm just trying to change looks, right, but not values. All right, so let's keep doing this. What do we get here in the numerator? So when we multiply it together, I get 8 times the square root of 15. Well, what's root 3 times root 3? Well, that's 3, because remember, square root of 9 is 3. So root 3 times root 3 is 3. 3 times 2 would be 6x. Now, guys, are we in simplest radical form? And the answer is no. The reason why we're not in simplest radical form is really we're not just, actually I take that back. The radical is in simplest form, but is the fraction my final answer in simplest form? No, I have to take 2 out of the 8 and the 6. So I end up getting 4 root 15 over 3x for our final answer. All right, let's try this a little bit more. Some of you are like, my head hurts. This has been so long. I never learned this in the first place. You've got to know it. Okay. This is not like, oh, tomorrow you can figure it out. No, we're going to be using it very next week. We're going to be simplifying. So we have to know how to work with these values. Let's do a little more practice, but I put this in purple because it's my favorite color, but also just because I want you to remember this. Never, ever leave a radical in the denominator of a fraction. Ever. Always rationalize the denominator. And so we're going to do some practicing of that so you guys feel more confident. All right, first things first, I wanted to do these because I want to remind you this is why how we rationalize, or why we do. Guys, what is the square root of 8 squared? If I square a square root, the number comes out. Now, if you need to show work, you can always do it this way. And then you can sit there and get square root of 64, which is 8. To me, you should know it's 8. But if you need to do more work, that's totally fine. All right, now what's the square root of 17 squared? Well, remember what happens to the radical and the squared. They do what? Simplify each other out, and you get 17. All right, yay. Now let's practice a little bit more. I have 3 over the square root of 6. Now, did any of you go like this? Well, the problem is you can't do that because 3 is not a radical. You cannot simplify that way unless it's a radical. So they either have to both be underneath the radical or they're both outside the radical in order for you to simplify. But instead, I got to go, oh no, I need to rationalize the denominator. So I need to multiply the numerator and denominator by the same thing. Well, looks like Mrs. Young. Oops, let me do this. I got to get out of my working on our stuff here, my friends, for this next week. Teacher's job's never done. And yes, I know it's 10:14 on a Saturday night. I love you guys if I'm doing this. All right, so this first thing here, I have to rationalize the denominator. So back to focus here. I have to multiply by the same thing, numerator and denominator, right, by the same radical. We pick the one that's down below. So I get 6 and 6. So the numerator comes 3 root 6. Now what becomes the denominator? What's root 6 times root 6? That's the square root of 36. So what's the square root of 36? 6. Now let's simplify. Because now that the 6 is out of the denominator, I got 3 and 6 here. That reduces down to root 6 over 2, because remember I have to simplify those two. And that will be your final answer. All right, let's try one more. All right, let's multiply together first. I got 7 over the square root of 2 times 4 over the square root of 3. So I get 7 times 4, which is 28, over what's root 2 times root 3? That's root 6. Rationalize the denominator. So I get 28 root 6 over 6. Simplify, guys. What comes out of both 28 and 6? 2. So that becomes 14 root 6 over 3. Okay, so the worksheet's pretty short and simple. I only gave you 15 problems. A couple of them is like stretch and just combining and reviewing. So some will be probably pretty easy. Some might be a little bit more like, I'm not quite sure, but I want you to try all of them. Guys, don't be afraid to come in for extra help on this, because this is just a key thing you need to know. And hopefully you remember this quite well, and so we can just keep rolling in geometry class, but come in for help if you need it. Thanks, guys.